Shivansh Electronics presents the MOTU M2 Technical Masterclass. 2 inputs, 2 outputs, studio-grade specs that shame interfaces costing 5 times more. Let's break down why this changes everything.
The same ESS Sabre32 Ultra DAC technology inside $60,000 headphone amplifiers. That's what powers the M2's conversion stage. This technical analysis reveals how MOTU brought reference class performance to the desktop, backed by the ES9016S architecture that defines modern high fidelity. Here's the uncomfortable truth for premium interface manufacturers. 120 decibels of dynamic range, powered by ESS Sabre32 Ultra DAC technology at 28,000 rupees. Standard entry-level interfaces deliver 108 decibels. Reference converters above a lakh deliver 120. The M2 matches reference performance at entry-level pricing, a statistical anomaly in the market. 4 decades of precision engineering led to this moment. ESS Technology began in 1983 at Berkeley's physics department. By 2001, they acquired Silicon Analog Systems, the very foundation of Sabre architecture. The 2016 Hyperstream 2 introduction now powers devices from the $60,000 Sennheiser HE1 to the MOTU M2 on your desk. Traditional Delta Sigma converters face an engineering dilemma: push for performance and risk instability. ESS solved this with Hyperstream. Instead of single-bit quantization that becomes unstable at high modulation, the multi-bit architecture achieves 100% modulation depth with unconditional stability. Aggressive noise shaping without compromise. Quantization noise doesn't disappear, it gets relocated. Fifth-order noise shaping combined with 64 to 128 times oversampling pushes all artifacts far above audible frequencies. The result, a theoretical 20 decibel gap between 24-bit limits and practical reality, with silence preserved across the entire audio band from 20 Hz to 20 kHz. Manufacturing perfection is impossible, but ESS found an elegant workaround. The Revolver DEM algorithm continuously randomizes which internal elements process the signal. Component mismatches that would normally cause harmonic distortion get converted into mathematically insignificant broadband noise. The result, total harmonic distortion plus noise is measured at minus 110 decibels. USB clocks are notoriously unstable, and jitter destroys high-resolution audio. The MOTU M2's time-domain jitter eliminator uses a digital phase-locked loop to calculate true 32-bit sample timing, then resynchronizes everything to a local low-jitter oscillator. Your converter performance becomes completely independent of source clock quality. 7.96 picoseconds. That's the maximum jitter tolerance for 120 decibel performance at 20 kHz. Timing precision measured in trillionths of a second. ESS implementations achieve sub-picosecond equivalent jitter, rendering timing errors mathematically inaudible. This is where engineering meets the limits of measurability. 120 decibels represents a 1 million to 1 voltage ratio between maximum signal and noise floor. This matches the instantaneous dynamic range of human perception itself. The M2 measures 120 decibels against the ES9016S chip limit of 124. Beyond this threshold, improvements serve engineering margins, not audible fidelity. 0.00032%. That's the MOTU M2's total harmonic distortion plus noise figure, which is minus 110 decibels. Human audibility thresholds for distortion sit around minus 60 decibels. The MOTU M2 delivers distortion 50 decibels below what humans can perceive, ensuring absolute signal transparency from input to output. More channels, less noise. It's elegant mathematics. The ES9016S contains 8 internal DAC channels. The M2 sums 4 channels per stereo output. Random noise averages out while signal remains coherent. Square root of 4 equals 2. That's a 6 decibel improvement in noise floor through architecture alone. Not all converters are created equal. ESS Hyperstream 2 delivers 124 decibel theoretical DNR with analytical precision. AKM's Velvet Sound architecture reaches 123 with a warmer character. Cirrus Logic and TI Burr Brown sit at 115 and 112 respectively. The M2 leverages flagship-class silicon, dramatically outperforming the 108 to 112 decibel chips typical at this price. Marketing claims mean nothing without third-party verification. Julian Krause confirmed exceptional converter performance through loopback testing, identifying the headphone amplifier as best-in-class among budget interfaces. Audio Science Review measured balanced output SINAD at approximately 110 decibels, recommending the MOTU M2 for its exceptional performance-to-cost ratio. These equations govern everything. Signal-to-quantization noise ratio depends on bit depth and oversampling. Noise shaping follows the transfer function. Jitter SNR relates to timing, precision, and frequency. Channel summing provides logarithmic gains. Thermal noise sets the absolute floor. Every MOTU M2 specification traces back to these mathematical foundations, validated against ESS datasheets. Exceptional converters exist. Competent engineering exists. Rarely do they meet at this price. The MOTU M2 sits precisely at the intersection. proven 32-bit architecture, mathematical noise shaping, and jitter elimination combined with implementation expertise. A transparent window into the audio signal that satisfies both creative musicians and measurement-focused engineers. Everything downstream depends on what happens here. The microphone preamplifier sets your recording's noise floor permanently. No amount of processing can recover what's lost at this stage. The MOTU M2 employs the THAT Corporation 6263 silicon preamplifier, transforming delicate microphone signals into pristine digital output through precision gain architecture. Here's why preamp quality matters more than anything downstream. The Friese formula proves it mathematically. Total system noise is dominated by F1, the first stage noise factor. Subsequent stage contributions get divided by preceding gains. A noisy preamp permanently compromises the signal chain. Excellence at the input means excellence throughout. Physics sets an absolute floor no engineer can breach. The Johnson-Nyquist equation calculates thermal noise from Boltzmann's constant, temperature, source impedance, and bandwidth. For a 150 ohm source across 20 kilohertz at room temperature, 222 nanovolts RMS. That translates to minus 130.9 dBu, the theoretical physical minimum. Most manufacturers won't tell you what's inside their preamps. MOTU uses the THAT Corporation 6263, a digitally controlled preamplifier with integrated ADC buffer from Milford, Massachusetts. Minus 8 to plus 34 decibels native gain range, 3 decibel digital steps via SPI interface, all consuming just 60 milliwatts. Purpose-built for USB bus efficiency. Ever heard a click when adjusting gain during recording? That's zipper noise, and the THAT 6263 eliminates it. The chip waits for the audio waveform to cross 0 volts before executing any gain change. Signal at silence means no discontinuity. Smooth, artifact-free adjustment regardless of how quickly you turn the knob. 1.9 decibels. That's all that separates the MOTU M2's measured EIN from the laws of physics. At minus 129 dBu, the preamp sits just above the minus 130.9 dBu thermal noise floor. 98% of noise performance is limited by physics itself, not circuit imperfections. Sound-on-sound review data confirms exceptional design. 60 decibels of clean gain from a USB-powered interface. The MOTU M2 achieves this through hybrid architecture. The THAT 6263 provides minus 8 to plus 34 decibels of variable gain, followed by a fixed post-amplification boost stage. Digital SPI control ensures precise 3 decibel steps across the entire range. The Shure SM7B question. At minus 59 decibel volt per Pascal sensitivity, quiet sources at 50 decibel SPL targeting minus 18 decibel full scale require approximately 93 decibels of gain. The MOTU M2's 60 decibels handles normal speech comfortably, but whisper quiet sources with this gain-hungry microphone sit at the margin. Know your application. Ribbon microphones demand careful matching. Active ribbons like the Royer R122 include internal preamps, connect directly to the MOTU M2 with confidence. Passive ribbons like the R121 require assessment. Loud sources work at maximum gain, but quiet sources may need an inline booster like the Cloudlifter for an additional 25 decibels. Stop recording hot. With 115 decibels of ADC dynamic range, targeting minus 20 decibel full scale still leaves 95 decibels of signal-to-noise ratio below your recording level. Better than CD quality. The digital noise floor becomes negligible compared to preamp noise. Protect your headroom, forget the old 16-bit mentality. 48 volts plus or minus 4 volts. That's the IEC 61938 standard for phantom power. The MOTU M2 implements individual switching per channel through precision 6.81 kilo-ohm resistors with 0.4% tolerance. This maintains proper headroom for demanding condenser microphones from Schoeps, Neumann, and other professional manufacturers. Plug your guitar in wrong and you'll lose all your highs. The rule: load impedance must exceed 10 times source impedance. Guitar pickups run around 10 kilo-ohms. The MOTU M2's high impedance input presents 1 mega-ohm, a 100-to-1 ratio. Full frequency preservation from 20 Hz to 20 kHz. No treble loss, no dull tone. Analog saturation forgives. Digital clipping doesn't. The MOTU M2 accepts plus 10 decibel unloaded at minimum gain with an internal clip point at plus 16 decibel unloaded. Unlike analog's soft knee harmonic distortion, digital clipping creates a hard wall, harsh distortion, and permanent data loss. The MOTU M2's transparent design demands proper gain staging. THAT Corporation 6263 silicon, minus 129 decibel unloaded equivalent input noise, just 1.9 decibels above physics limits. 0 to plus 60 decibels gain range, 1 mega-ohm high impedance input, individual 48-volt phantom switching, 115 decibel ADC dynamic range. Professional engineering in a compact chassis. Your monitors tell half the story. Your headphones reveal the rest. The MOTU M2's headphone amplifier isn't an afterthought. Built around the Texas Instruments OPA 1688, it delivers 75 milliamps of output current with total harmonic distortion plus noise at 0.0001%. Purpose-built amplification preserving ESS Sabre32 conversion quality. Purpose-built for reactive headphone loads, the OPA 1688 delivers THD plus N at -109 decibels, driving 50 milliwatts into 32 ohms. Rail-to-rail output with 8 volts per microsecond slew rate ensures fast transient response. Plus or minus 75 milliamps per channel with short-circuit protection. 10 MHz gain bandwidth handles everything from 16 ohm IEMs to 600 ohm reference monitors. Damping factor quantifies amplifier authority over headphone drivers. The formula, load impedance divided by output impedance. At 0.05 ohms, the MOTU M2 achieves 640-to-1 damping into 32 ohms, 6,000-to-1 into 300 ohms, 12,000-to-1 into 600 ohms. Minimum recommended is 8-to-1. The MOTU M2 exceeds this by orders of magnitude. The 1/8 rule prevents frequency response deviation. Amplifier output impedance must stay below 12.5% of headphone impedance. High output impedance causes audible coloration, 2.37 decibels at impedance peaks. The M2's 0.05 ohms produces just 0.0014 decibels deviation, essentially flat response regardless of headphone impedance curve. The Sennheiser HD650 presents a challenging impedance curve, spiking to 500 ohms around 100 Hz for its signature bass emphasis. High-output impedance amplifiers artificially reduce this emphasis, changing the headphone's character. The M2's near-zero impedance preserves the native 4.4 decibel bass emphasis exactly as Sennheiser intended. Power equals voltage squared divided by resistance. High-impedance headphones above 300 ohms need voltage swing, limited by USB bus power to approximately 3.3 volts RMS. Low-impedance loads below 64 ohms need current delivery. The OPA 1688's plus or minus 75 milliamp capability favors efficient low-impedance headphones. 2.5 watts, 500 milliamps at 5 volts. That's the total USB 2.0 power allowance. The MOTU M2 must divide among ESS DAC, ADC, digital processing, preamps, phantom power boost, LCD display, and headphone amplifier. Bus power design means real engineering trade-offs. Driving 600 ohm headphones to concert levels requires external power solutions. Real numbers across real loads. At 32 ohms, you get 50 milliwatts. Current limited, easy drive. At 80 ohms, you get 134 milliwatts. Optimal matching. At 300 ohms, you get 36 milliwatts. Voltage limited but sufficient for critical mixing above 102 decibel peaks. At 600 ohms, you get 18 milliwatts. Moderate levels only. Know your headphones? Understand the physics. Match your tools to the technology. The Audio-Technica ATH-M50X at 38 ohms and 99 decibels per milliwatt requires 58 milliamps for 110 decibel peaks. The OPA 1688 delivers 75. The Sony MDR7506 at 63 ohms needs just 25 milliwatts. Low-impedance, high-sensitivity headphones unlock the MOTU M2's full potential. Can a bus-powered interface match dedicated headphone amps? The Shiat Magni Heresy pushes 2,400 milliwatts, 50 times the MOTU M2's power. But quality metrics tell the real story. All three achieve minus 110 decibel total harmonic distortion plus noise, which can be abbreviated as THD plus N. The MOTU M2 trades raw power for integration via its DAC, ADC, and MIDI in one USB-C cable. Which headphones pair perfectly? Excellent matches are Audio-Technica ATH-M50X, Sony MDR7506, Beyerdynamic DT770 at 80 ohms. Adequate matches are Sennheiser HD650 at 300 ohms. An audio interface with an external supply, such as the MOTU M6, matches the 600 ohm variants. Otherwise, there can be inefficient planar magnetics below 90 decibels per milliwatt for the bus-powered ones. Latency destroys recording sessions. Delayed monitoring disrupts pitch accuracy and timing. The MOTU M2 addresses this with two solutions, such as the hardware direct monitoring bypassing digital entirely, and record-breaking 2.5 millisecond digital performance. Engineering that removes barriers between performance and capture. Follow the signal path, which starts from microphone to preamp, ADC, USB to computer, through plugins, back across USB, through the DAC to headphones. At typical buffers, this accumulates 10 to 20 milliseconds, enough to disrupt vocal pitch and rhythmic timing. The MOTU M2 offers two distinct solutions. What if monitoring required no digital processing? The MOTU M2's analog short-circuit routes input directly from preamp to outputs, completely bypassing the ADC. Press the MON switch. It provides zero latency, limited only by electrical propagation. Recording proceeds normally, only monitoring takes the analog shortcut. Single press enables mono monitoring. Input centered to both outputs. ideal for vocals. Press and hold for stereo link. Input 1 routes left, input 2 routes right, essential for stereo synths. Hardware logic eliminates software control panels. The display confirms routing instantly. No physical mix knob, by design. Need more backing track? Raise the DAW fader? Need live microphone on top? Lower playback. For custom mixes with effects, disable MON and use software monitoring, but this depends on buffer size. The DAW fader becomes your monitor mix controller. When software monitoring is required, the MOTU M2 sets the benchmark. At 96 kHz with 32 samples, 2.5 milliseconds round trip. Standard interfaces hit 8 to 10 milliseconds. Focusrite Scarlett Generation 3 hits approximately 6. Lower than 3 milliseconds is perceptually instantaneous for virtual instruments. Round-trip latency is math, not magic. Buffer samples times 2, divided by sample rate, plus converter latency, plus driver overhead. At 96 kHz with 32 samples, buffer contribution is 0.67 milliseconds. Higher sample rates mean less latency per sample. Independent testing confirms the claims. 96 kHz, 32 sample provides 2.5 to 3.2 milliseconds. 48 kHz, 64 samples provides 5.5 to 6.2 milliseconds, which is a standard live tracking configuration. MOTU Nation community data validates the MOTU M2 as the latency leader in its class. Standing 2.4 meters from an amplifier creates 7 milliseconds of acoustic delay. Musicians accept this as normal. Sub-7 millisecond digital latency equals arm's reach. But at 32 samples, processing margin is razor thin. Use 64 to 128 samples for stable live tracking. Platform determines your path to low latency. Windows requires ASIO drivers, bypassing the OS mixer for direct hardware access. Buffer adjustable from 16 to 2048 samples. Mac Core Audio offers approximately 7 milliseconds class compliant with optional MOTU drivers enabling loopback and lower latency. One interface, multiple platforms. USB-C iPad Pro provides direct connection with bus power. Lightning devices require a powered hub plus camera adapter. The Lightning port can't supply sufficient current alone. Class compliance ensures instant functionality on Linux, Mac, and iOS without drivers. Streamers need computer audio in their recordings. Inputs 1 and 2 carry physical sources. Inputs 3 and 4 capture loopback. Spotify, Zoom, game audio. Inputs 5 and 6 provide a pre-mixed sum ready for OBS. One interface handles voice, playback, and guests simultaneously. The technical foundation consolidated. Conversion via ESS Sabre32 Ultra DAC providing 120 decibel range. ADC inputs of -129 decibel unloaded EIN with individual 48-volt phantom. Speed of 2.5 milliseconds round trip. Outputs via DC coupled TRS plus RCA mirrored. Display of 160 by 128 pixel LCD. Specifications tell one story. Build quality tells another. 4 decades of professional manufacturing experience shaped the MOTU M2's industrial design. From extruded aluminum to digital encoders, every element serves function and durability. Professional studio engineering in a desktop form factor. Sound on Sound called it wrapped in cold, hard metal, over-engineered to mitigate any risk of accidental damage. Extruded aluminum outer shell with internal steel shielding. Weight of 1.35 pounds, substantial enough that cable tension won't drag it. Professional-grade construction for years of service. Desktop space is precious. The MOTU M2 is of 7.5 by 4.25 inches. Focusrite Scarlett 2, i2 is of 6.85 by 3.74 inches. SSL2 is of 9.4 by 6.5 inches. Audient ID4. Mark II is of 5.8 by 4.3 inches. The MOTU M2 balances metering with compact footprint. Most budget interfaces offer basic LED ladders. The MOTU M2 provides full-color LCD metering of 160 by 128 pixels, covering 60 decibels. That's 0.375 decibel per pixel, precise enough to distinguish -18 from -20 decibel full-scale targets. Visual precision transforms gain staging. Peak metering captures instantaneous maximums, essential for avoiding digital clipping. RMS shows perceived loudness. Music crest factors reach 12 to 20 decibels between peaks and RMS. The MOTU M2's meters respond to peaks, protecting against transients that averaging would miss. -18 decibel full scale means 18 decibels of headroom. Shielding determines whether you record signal or interference. 20 decibels equals 99% power reduction. 40 decibels equals 99.99%. The MOTU M2's aluminum and steel construction exceeds commercial requirements, attenuating external fields before they reach sensitive circuits. Metal shielding has frequency-dependent limits. At 60 Hz, skin depth in aluminum is 10.6 millimeters, exceeding typical chassis thickness. Low-frequency hum passes through. At 20 kHz, just 0.58 millimeters. The solution? Balanced connections with high CMRR cancel what shielding cannot stop. Electronics generate heat. The MOTU M2 dissipates it without fans. 2 watts consumption, 20 degrees Celsius per watt thermal resistance. Calculation: 40 degrees rise above ambient. Aluminum's 205 watts per meter Kelvin conductivity spreads heat evenly. Passive cooling means zero fan noise contaminating recordings. Continuous digital encoders, not analog pots prone to drift. Benefits: perfect left-right tracking at low volumes, exact repeatable settings, 1 decibel step resolution. Individual 48-volt buttons per channel protect ribbon mics. The large monitor encoder matches gain control precision. Digital accuracy with tactile feel. Connectors often fail before electronics. USB Type-A, 1500 cycles rated. USB Type-C, 10,000 cycles, nearly 7 times better. 10,000 divided by 4 daily connections equals approximately 6.8 years of operation. Modern connectivity engineered for long-term professional service. Most interfaces block DC through coupling capacitors. The MOTU M2's outputs are DC coupled, passing voltage to 0 Hz. For modular synths, 1 volt per octave, plus or minus 3.6 volts, spans approximately 7.2 octaves. Use floating ring cables, TRS to TS with ring disconnected, to avoid shorting. The ADC completes the conversion story. A KMAK 5552VN Delta Sigma architecture with 32-bit processing. 115 decibel dynamic range A-weighted. Total harmonic distortion plus noise abbreviated as THD plus N at minus 106 decibels. CMRR at 80 decibels reduces 10 millivolts of hum to 1 microvolt. Broadcast quality input conversion. What do users praise? High-resolution LCD metering, robust metal chassis, 2.5 millisecond latency, individual phantom power. Professional engineering in desktop form. 1.35-pound aluminum and steel chassis. EMI shielding exceeding 20 decibels. 160 by 128 pixel LCD with 0.375 decibel precision. 10,000 cycle USB-C, ESS Sabre32 Ultra DAC. Flagship specifications, accessible pricing. Hardware is half the equation. MOTU bundles Performer Lite. Genuine production capability, not demoware. 16 stereo audio tracks, 16 MIDI tracks, over 100 virtual instruments including pianos, synths, orchestral. The 16-track limit accommodates most home recording and podcasting workflows. Prefer industry-standard workflows? Live Light included. 8 audio or MIDI tracks, 8 scenes, 4 bundled instruments. 6 gigabytes of loops from Big Fish Audio, Lucid Samples, Loop Masters. 2 professional DAWs with your interface. Choose the workflow matching your creative approach. Content creators need complex routing without complex configuration. Hardware inputs 1 and 2 is for microphones. Loopback 3 and 4 is for system audio. Mix channels 5 and 6 is for combined feed for OBS or Discord. Mac requires driver installation for Loopback. No third-party virtual cables needed. Plot price against measured performance. An anomaly emerges. Entry-level interfaces are generally $100 to $150, providing standard measurements. Premium competitors are generally of $250 to $300 with higher specifications. The MOTU M2 sits alone with an MRP of 28,000 rupees, pricing delivering elite-tier ESS Sabre32 Ultra DAC conversion. Categorical market disruption. The Shure SM7B test. Microphone output, minus 69 decibel volt. Target output is minus 18 decibel full scale. Required output is 67 decibels. The MOTU M2 provides 60 analog, with 7 clean digital remaining. For normal speech, it's sufficient. Whisper quiet sources such as cloud lifters are recommended. Ultra-low noise floor means maximizing gain won't introduce hiss. Does 120 decibels matter practically? CD noise floor is of minus 96 decibel full scale. MOTU M2 noise floor is of minus 115 decibel full scale, 19 decibels quieter. Recording at conservative minus 18 still yields 97 decibel signal to noise. 45 decibels better than vinyl. Massive headroom without sacrificing quality. When does distortion become audible? Pure tone threshold of approximately 0.1% total harmonic distortion. Music masking is from 1 to 10%. The MOTU M2 measures 0.001%, 100 times better than audibility threshold. The transparency gap between converter performance and perception is unmeasurable. Marketing needs third-party validation. Audio science review. Balanced SINAD approximately 114 decibels, excellent filter cutoff. Verdict, happy to recommend. Julian Krause, RTL confirmed at 2.3 to 2.5 milliseconds. Headphone amp excellent versus competitors. Independent findings match MOTU's claims. 2 niche capabilities extend value. Modular users. DC coupled output supports 7.2 octaves of CV. 24-bit precision exceeds pitch accuracy requirements. Mobile creators, USB-C iPad Pro connects directly. Lightning devices need powered hub plus camera adapter. MOTU Pro audio performance, anywhere. Zero latency analog path. 2.5 millisecond digital loop. ESS Sabre32 conversion. THAT Corporation preamps. Professional build quality. Single USB-C connection. Entry-level pricing. 4 decades of expertise condensed into one interface. Professional performance wherever creativity takes you.
That's the MOTU M2, engineering excellence that redefines what's possible at this price point. Shivansh Electronics is the authorized distributor of MOTU-Audio interfaces in Eastern India. For detailed technical assessments, performance analysis, or any queries about the MOTU M2, reach out to us at our Kolkata showroom. For the best deals on any audio interface from MOTU, Mark of the Unicorn, a renowned USA-based brand celebrated for its precision-engineered audio interfaces, reach out to us directly. Call us on the mentioned mobile numbers, which are 983-166-2458 or 8981807755 or 9147700677. Follow us on Facebook and Instagram at ShivanshElectronics.in. Follow us on LinkedIn and subscribe to our YouTube channel at Shivansh Electronics-in and hit the bell icon for notifications on professional audio insights and technical masterclasses like this one. All links are in the description below. Thanks for watching. We'll see you in the next video.